Hi folks, welcome again in Eng-Man YouTube channel. So today is a very brief video. It's again about reservoir simulation using tNavigator software. And now we are using Model Designer. Okay, and today's topic we will edit properties. It's a very simple, but this is the first step. So you need to know this. It's simple, but of course it's very fundamental. All right, as usual, we will use the template case, the example case provided by tNavigator. All right, so I'm going to start with, you can see here the visible wells. If you uncheck, there you go. And then to show the grid, here we have 3D grids, main grid, or in this case, we have black oil demo. Okay, so click on that. You can switch from 2D, 2D map, or 3D model. Again, if you change to 3D, you need to select this. All right, and then right click here and then adjust size by data to make it more, this is the proper sizing. All right, I'm going to start with this and then let's open the tree, open the properties. Now we are looking at the net to gross and then go to grid here, black oil demo, and then click on show palette so we can see the net to gross distribution. All right, what do we have here? So in our initial properties, we have the agnum. This is usually to, to make a zonation where are the zones with the active grids and where are the zones where the active are not active, where the grids are not active. Okay, so we use agnum for that, and then porosity. So this is the proper porosity, net to gross, and permeability along X. Okay, you can see the value on the palette. And let's say, after testing, after history matching, I think I need to adjust the properties, but I still need to maintain the existing grid properties, the original grid properties of the permeability along X. So what do I need to do? You can right click on here and then duplicate. And then let's say we call it, it's another grid, and let's call it perm X copy, or just perm X like this. It is a permeability in X direction. The value is exactly the same with permeability along X grid here. But of course, we can modify the property here. And to modify, right click again, and then show calculations. And then calculator, you can do modification either using arithmetics, using block, or cylinder. We will try these three, right? These three options, but in this video, we will start with arithmetic. All right, so arithmetic, and then you can just type in, let's say you want to modify it with, you want to multiply it with 3. And then this one, 3 multiplied by the permeability along X, of course, like this. And this will be applicable for the entire grid. Click on apply. You remember this value, 748 millidarcies. And if you click on apply, you will multiply all of the grids with the factor of 3. And thus you can see now the maximum permeability, the highest permeability becomes 2246. The distribution will be the same throughout the reservoir, but all of the grids now will have permeability in X directions 3 times larger than the original properties. Okay. So again, we now have 2 options of permeability along X grid. You can select this one, all right? But you can also select this one. Both of them will be tested when you construct the reservoir model and reservoir simulation. When you run the reservoir simulation and you compare the cases until you can find which permeability in X direction distribution that is reliable, that will be used for later field development planning. Okay, field depletion planning. This is a very simple approach. This is a very simple method, but this is the fundamental. If you cannot do this, then it will be very difficult for you to, again, to create the another possibility of permeability in X direction on your static modeling, right? It will be hard work if you miss this step. Okay, so this is very simple. You can just duplicate the existing grid and then you modify a little bit using arithmetic. Okay, so I think that's all. I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching. See you again on the next reservoir simulation videos. Thank you.